So we're going to do more limits. We're going to do limits of piecewise functions. That's what we're going to do on this side. And then we're going to do the limits to infinity and negative infinity. That's the other side. So we're going to start with this one here. So this is a piecewise function that has been broken into 5 pieces. So when we talk about them, we're going to call them the first part, the second part, the third part, the fourth part, the fifth part. Do you understand what I'm saying? So we can communicate about it. So when you are doing limits of a piecewise function, all you have to do is make a decision. I know that decision making can be hard about which piece of the function you're using. And then all you do is plug the number in. That's all that it is. Okay. So looking at this one, limit as x goes to -3. Which piece of the function does -3 live in? And you're going to look at these pieces of information over here. So which piece of the function is -3 in? The first one, do you see what I'm saying? -3 is smaller than -1. All you're going to do is plug in -3. So it'll be 1 over -3 squared. Just, hey, Miss Cole, you just plugged it in? Yep, that's it. And so what's that going to equal? 1/9. That's all you got to do. So for this one, which piece of the function does 5 belong in? The fifth one. 5 is bigger than 2. All right, so all you're going to do is plug in 5 to that piece of the function and see what you get. So is that -1/9? 5 minus 2 is 3 squared is 9, so -1/9. Weirdly, that's kind of weird that one came out to 1/9 and the other one was -1/9, but hey, it's whatever. All right, this is 3/2. What is 3/2 as a decimal? It's 1.5, 1 1/2. So which piece of the function does 1 1/2 live in? The fourth, good. So you're going to do 1 1/2 plus 1, which would be 2 1/2. Or as a fraction, what would that be? 5/2. Good. All right, now we're going to do from the left and from the right. So this is -1 from the left. -1 is one of the places where it got cut. But if you want to do from the left, which piece has numbers to the left of -1? The first one. See how numbers smaller than -1? So all you're going to do is plug -1 into that piece of the function. Again, it's just making a decision about which piece you're using. If you absolutely lose your mind, pick one and go for it. You know. So what is that going to equal? 1. 1 over 1 is 1. Now we're going to do -1 from the right. So which piece of the function has numbers to the right of -1? Yeah, the second one, which there's nothing to plug in there. It's just 2. And then this says -1, but it's overall. I don't even need the equation at this point. Look, from the left, it was 1. From the right, it was 2. So what is this answer? From the left, it's 1. From the right, it's 2. 1 went here and 1 went here. Thank you. What kind of discontinuity is that? Jump. Are you guys visualizing this? One side went to 2 and the other side went to 1. Let's try it again. Now we're going to approach +1 from which side? The left. Okay, so which piece of this involves numbers to the left of +1? The second one. Do you see numbers smaller than 1? Now there's nothing to plug in there. It just comes out to 2. Now you want to approach 1 from the right. So which piece of this involves numbers to the right of 1? The fourth one. Do you see x bigger than 1? Now, if you plug 1 into that, 1 plus 1, 2. So now I don't need the equation anymore. Now I want 1 overall. So look at, from the left, it's 2. And from the right, it's 2. So the answer is 2. If from the left, it's 2. And from do you remember zooming in on the point? Remember I used the microscope as an analogy, like you zoom in and from this side it's 2 and this side it's 2, the answer is 2. But if from that side it's 1 and that side it's 2, then the answer is it's a jump, so it's pulling teeth with you guys. All right, now we're gonna do 2. 2 from the left. Which piece of the function would we use that has numbers to the left of 2? The fourth one. Good. So you're gonna plug in 2. 2 plus 1 is 3. 2 from the right. Which piece involves numbers to the right of 2? Last one. So we're going to plug 2 into that, the fifth one. So you're going to have -1 over 2 minus 2 squared. Now that actually ends up being an issue because that's going to give you -1 over what? 0. That is an undefined slope. Do you remember from algebra 1, 0 slopes and undefined? There's an asymptote there, vertical asymptote. If there is a vertical asymptote, the graph can only do one of 2 things. It can either go up or go down. So you just need to pick a number that's bigger than 2, like 3, and plug it in and see if you get a positive or a negative result. Okay, so let's plug in 3 to this. 3 minus 2. 1 squared is 1. -1 over 1 is -1. We got a negative result, so it's going to go down, -infinity. If there is an asymptote, it either goes up or goes down. You have a 50-50 shot, but you just pick a number. Like, why did we pick 3? Bigger than 2. It says to the right of 2. Just pick a number, plug it in, see if it comes out positive or negative. Now, I don't need the equation anymore. This is 2 overall. I hope this isn't like pulling teeth. From the left, it's 3. From the right, it's -infinity. So what do you think the overall answer is? Yeah, those do not meet up. There's an asymptote, the problem. So go ahead and flip over. Those were the piecewise ones. You just pick which piece of the function you're using. Now we're going to do to positive or negative infinity. I call this who's in charge here. You've done this before. We did this back in the rational unit, okay? But I put it on here for you. If the numerator degree is smaller than the denominator degree, it's automatically 0. Here's how my brain does that. The numerator is smaller. When you go out to infinity, here's what happens. You get a pattern like 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, until you get out to 1/1,000,000th. Some of you won't even look at me. And what is 1/1,000,000th super close to? 0. It's going to level off at 0. You're understanding what I'm saying? All right. If they equal each other, as a tiebreaker, you're going to use coefficients. It's written on the paper. I'm literally just asking you to read. Your leading coefficients. And then if your numerator degree is bigger than your, I should have put denominator degree, you get the slant asymptote. Do you remember those? It's either up or down. You got a 50-50 shot. You're going to do what we just did, plug in a number and see if it comes out positive or negative. Now, sometimes you have other types of functions in there. So if it's who's in charge here, an exponential grows faster than a polynomial, which grows faster than a logarithmic. So if you're not sure who's in charge, that's the order it goes in. This is only for positive and negative infinity. If you're approaching a number, this doesn't work, right? Looking at the first one, I need you to talk to me. Who is in charge for the numerator? The biggest power is the one in charge. The 4x cubed. There we go. Gosh, it is like torture with you guys. I have to re-record this tomorrow. All right, who's in charge of the denominator? There we go. What do you notice about them? They're the same. So you're going to use coefficients. So 4/5. Let's try again. Who's in charge of the numerator? X. Good. Who's in charge of the denominator? Good. So it's x to the 1 over x to the 3rd. So which one of these situations is that? Good. The numerator is smaller, so it is automatically 0. Who's in charge of the numerator for this one? 5x cubed. Good. In the denominator, careful because it's actually -x squared. So the numerator is bigger than the denominator. It is either going to be positive or negative infinity. So if you aren't sure, just take a guess. You got a 50-50 shot. But you can't plug in infinity. We're going to plug in a number in our minds mentally. You can't plug in infinity. Infinity is not a value. So what I want you to do is think of the biggest number you can. Okay? Like 100 million bajillion. If you take that really big number and cube it, it is still a really big number. If you multiply it by 5, it's still a really big number. But the point is, it's positive. Down here, if you take a really big number and square it, it is still a really big number. But then you're going to make it negative. So if you have a positive divided by a negative, negative infinity. It's either going up or down. You're just testing at that point. All right, let's try it again. Who's in charge of the numerator? X to the fourth down here, X to the second. The numerator is bigger than the denominator, so it's either positive or negative infinity. We're going to do the same thing we did here and test it. Now this one is going to negative infinity, so you have to think of a really large negative number, like negative a million. You take a negative million to the fourth. It's going to be positive. Even powers turn it positive. So same thing down here. If you take a negative, really huge number and square it, it's going to be positive. So positive infinity. You're just testing positive or negative. All right, for this one. For the numerator, it's x. I'm actually going to circle the negative with that. It's negative x. You have to put the negative somewhere. And then square root of x. Let's see who remembers this. What is the power for a square root? It would be x to the what? What is that? 1/2. Good. 1, x to the 1 is bigger than a half. So it's either positive or negative infinity. Which do you think? It's the same thing we did with each of these. Why would it be negative infinity? Because there's a negative. Good job. All right, for this one, in the numerator, who's in charge? Well, 4, it's the only thing there. But if you want to put an x to the nothing to let you know that power is 0, that's not a bad idea. And then down here, it's the 3x squared. So which situation is that? Up top, you have x to the 0. On the bottom, you have x to the second. Automatically going to be 0. Numerator smaller than the denominator. For number 7, I'm going to ask you to remember a logarithm rule, but I taught this to you and it wasn't that long ago. Do you remember the rule that says you're allowed to take this power and write it out front? Remember, I drew an arrow like that is what it looked like. Okay, so take that 3 and put it out front. We're just going to kind of scribble it out there. So in the numerator, you've got 3 ln of x. In the denominator, you've got ln of x. That's a tie. They're both ln. So what do you use when it is a tie? Good, which is 3 over 1, which is just. All right, who's in charge of the numerator for this one? 3x squared. Now denominator's tricky. X is a polynomial. Polynomial is x or x squared or x to the third, or x. That's what a polynomial is. And then this is logarithmic. So if you look back to what I showed you here, a polynomial grows faster than a logarithmic. So if it's who's in charge, it's the polynomial. Logarithmics are kind of lazy. They don't, like those sideways swoopy graphs, they're not going anywhere in a big old hurry, right? So that situation 2 is bigger than 1. It's either positive or negative infinity. What do you think? You got a 50-50 shot. It's positive infinity. You don't have any negatives anywhere, so it's going to have to be positive infinity. All right, for this one, you've got 2x for the numerator, and you've got ln of x for the denominator. A polynomial grows faster than a logarithmic. So your numerator degree is bigger than your denominator degree. This one beats this. It's kind of like rock, paper, scissors. This one, polynomial beats logarithmic. So it's either positive or negative infinity. And I don't see any negatives anywhere, so positive infinity. This one's really tricky because there's a cosine in there, but I taught you cosine graphs. What does a cosine graph look like? And I'll even take a hand motion. Remember this? It's stuck between what 2 numbers? Good, 1 and -1. In other words, itsy bitty numbers. You with me? Like tiny numbers. As we go out to infinity, this is going to stay between 1 and -1. And this is going to go to infinity, meaning it's going to get bigger and bigger and bigger and bigger and bigger. So you end up with a situation like this. Do you get what I'm saying? Imagine as many zeros after that as possible. What is that really, really close to? 0. It's going to go to nothing. it's hard to imagine super large numbers because as humans, we just don't have the brain capacity. I'm not insulting your intelligence. Like, I don't have it either. Do you get what I'm saying? Like, we can't think about infinity too much, so don't try too hard. All right, and then these last two are almost the exact same problem. What's the only difference between them? Like, the function's the same. What's the only thing I changed? Yep, good. Okay, so just be careful. For this one, who's in charge for the numerator? 4x cubed. Denominator, it is the exponential. Exponential is more in charge than a polynomial, which is more in charge than a logarithmic. So e to the x is going to grow so fast, it is going to eclipse this entirely. Do you get what I'm saying? The denominator is going to be like, remember how exponentials are like this? Opening your eyes is the first step to learning. Remember exponential? They go like this, swoop, growing exponential really, really fast. So you're again going to get a situation where the denominator is super huge like this. So what's that really, really close to? Going to go to 0. Now this one, your 4x cubed is still in charge for the numerator, but instead of being super important, because we threw that negative in there, it flips. It's the reciprocal, and it will be super unimportant. You get what I'm saying? Like, now we don't want that one. So now we want, now it's not 7x cubed, it's actually negative 7x cubed. So which situation do we have with that? 4x cubed, negative 7x cubed. Coefficients, they're the same. So use your coefficients. It will be negative 4/7.